Have you ever found yourself tangled in the complexities of CUDA programming, especially when it comes to calculating warp and lane IDs? It can be quite a puzzle, right? Well, today, we're going to simplify that for you. I totally get it. Many developers face this challenge when trying to optimize their CUDA kernels. You're not alone in wondering about the most efficient way to calculate warp and lane IDs. It's a common concern among programmers. Let's dive into the specific question at hand. One user recently asked, what's the most efficient way to calculate the warp ID and lane ID in a one-dimensional grid? They pointed out that while each thread knows its block index and thread index, the lane ID and warp ID aren't directly available. Sound familiar? Let's explore this together. So why is this important? Understanding how to efficiently calculate these IDs can significantly impact the performance of your CUDA applications. The warp size is typically 32, and knowing how to derive these values can help you optimize your code. And stick around. At the end of this video, I'll share a quick tip that could enhance your CUDA programming skills even further. To efficiently calculate the lane ID and warp ID in a one-dimensional grid, the user can start by defining the warp size. This is typically set to 32, as that is the number of threads in a warp. Next, the user can calculate the lane ID. This can be done by taking the thread index within the block and using the modulus operator with the warp size. After that, the user should calculate the warp ID. This is achieved by dividing the thread index by the warp size. If the user wants to ensure maximum efficiency, they can use bitwise operations instead. This involves using the bitwise AND operator for the lane ID and the right shift operator for the warp ID. Finally, the user should consider the performance implications. While these calculations are efficient, they can still add overhead if done for every thread. Therefore, it's essential to evaluate if they are necessary for the specific application. Fun fact, the term warp in CUDA comes from the idea of a group of threads executing in parallel, much like a warp of fabric being woven together. Pretty neat, right? Now, let's look at the answers provided by other users. An alternative approach suggests calculating the lane ID and warp ID directly using inline assembly. This method retrieves the values from special registers, which can be more efficient than traditional calculations. The user emphasizes that using these special registers can be risky, as the warp ID may not correspond to a zero-based ranking within the thread block. They recommend caution and refer to documentation for more details. Here's a pro tip. Always consider the context of your application when choosing how to calculate these IDs. Sometimes the simplest method is the most effective, but don't hesitate to experiment with different approaches. And there you have it. You now know how to efficiently calculate warp and lane IDs in a one-dimensional grid. Remember, optimizing your CUDA code can lead to significant performance improvements. If you found this video helpful, please subscribe for more tips and tricks.